Text, Accelerating Delivery with Metrics-Driven Insights, Virtual CTO Summit, June 2, 2020. Virtual CTO Summit Number 4, Managing Through Metrics, Thursday, July 16, 10 a.m. Pacific Time, 1 p.m. Eastern Time. CTO Connection, Share Problems. Get Answers. In partnership with AWS. With thanks to Code Climate.
I'm the VP of Engineering and Group Manager for Engineering Platforms at Indeed. I've been working as a software engineer and engineering leader for just about 25 years now, and the last 11 of those years have been with Indeed.
JackHumphrey.me, LinkedIn.com/in/LeeJack, Twitter.com/@YouKnowJack.
You can read more about me at the links there on the slide. On Twitter, I'm Jack. But I'm really excited to be here for the Virtual CTO Summit to talk about how we've used metrics-driven insights at Indeed to accelerate software delivery. And this all started towards the latter half of 2018, when there was a general sentiment at Indeed that it feels like we're not delivering as fast as we used to. We're not getting as much done in a given period of time. And if you think about it, this sentiment is really a form of hypothesis. And so we can restate it as the velocity at which we deliver software to production has decreased as we have grown. And we had grown a lot in the several years leading up to this point. So from there, you might say, great, this sounds right, we believe this. So how can we increase velocity and get more done each week? But this is the wrong question to start with. Instead, I think that the questions that you should be asking in a situation like this are more like, should we care about delivery velocity? Is this actually a problem? If it is a problem, how do we define velocity and how do we measure velocity? And if we can do those things, then, well, what should we do to actually increase our velocity? So let's dive into that first question, should we care? Well, at Indeed, we definitely care about it. We view velocity as a competitive advantage. We think that the faster we can deliver, the more we can learn, the more we can innovate. And I think we can harness kind of a virtuous cycle of productivity. And what I mean by that is, if it feels good as a developer to be going fast, then my morale is higher, my energy is higher, and my productivity increases. And of course, if you're delivering faster, you can get features and improvements in front of your users and actually help them do what they need to do. And indeed, we're trying to help people get jobs. It's our mission, and it's really important to us to be able to do that quickly. And it also helps to, if you can go faster, you're probably going to help your unit cost economics, your cost per unit of work.
Kaizen.
So the other thing that we embrace at Indeed is a philosophy of continuous incremental improvement, which you'll often hear referred to as Kaizen. And Kaizen, the Japanese word, literally translates to good change. So this philosophy encourages you to focus on good change. In the context of velocity, that means things like removing process bottlenecks or eliminating rework, reducing excessive communication, and all these kinds of waste that you want to get rid of. And in Kaizen, you always measure. You measure what you want to improve, and you stay open to change. You stay open to evolving over time based on what you're learning. And so we care.
How do we define velocity?
We want to improve velocity, but how should we define it? And very much linked to that, once we've defined it, how will we measure it? These two questions have to be sort of answered simultaneously. And that's what we were doing towards the end of 2018. And I'll tell you that I don't really believe there's any silver bullet here. There's no single best metric for measuring development velocity, but I'll talk about a few and kind of give you some context of how we thought about them.
Throughput.
The first is actually kind of a category of measurements that you can do around throughput. For example, the total number of changes that you're deploying to production over a given period of time. Or in Indeed's case, another one that we cared a lot about was experiment throughput, because we focus so much on learning what works in our products by running experiments. So we could look at that throughput as well. And if we step back and think about what throughput was looking like at Indeed, over the few years leading up to 2019, we had grown the number of people contributing to the code base more than 200%. But in that same period of time, we'd grown the amount of work delivered to production about 130%. And this might not be the kind of ROI that we'd like to see on growing our organization. In fact, we saw a decline of about 28% in per developer throughput. So looking at throughput sort of validates that initial hypothesis that I laid out. And then we go about the work of actually choosing whether or not we want to use throughput as our metric.
Delivery lead time, DLT, average time to delivery a unit of work to production. See also, cycle time, delivery lead time equals 12.5 days, in progress, 4.0 days, pending review, 2.0 days, pending merge, 3.2 days, pending verification, 2.8 days, pending closure, 0.5 days, close/in production.
And another metric that we looked at very closely was called delivery lead time, or DLT. And this is how long it takes you, on average, to get a unit of work into production. People talk a lot about cycle time, and this is another way to look at cycle time. So we define delivery lead time as the time from when a developer starts work on something to when it's live in front of users in production. And you can break that down into the series of states that work transitions through in your development cycle. In this example, I'm showing it starts with in progress, and then pending review, pending merge, pending verification, and so on until it's in production. And if you can measure how long it's in each of those states, that adds up to your delivery lead time. In this example, 12.5 days. And so delivery lead time is one I'm going to talk more about because we really liked it as a metric. But you can also look at other things. If you do Scrum, you can look at Scrum velocity, how many points your team is able to deliver per sprint.
Deployment frequency, how frequently you deploy code.
If you can also look at how often you're deploying to production, which is different from your throughput. This is the frequency at which you can get changes into production, which can be very meaningful for your velocity. You can look at work in progress, which correlates with things like delivery lead time and throughput. And work in progress, or WIP, is the amount of work that's partially finished at any moment in time and awaiting completion. And if you can limit WIP, you will actually help increase your throughput and increase your velocity. Because if it encourages you, putting WIP limits in place encourages you not to avoid maximizing each individual in the team in terms of the work assigned to them. And if you do that, your teams can deliver more, just like if you're driving on a highway and it's at 95% capacity, you're going to be going a lot slower because of traffic jams, and fewer cars are going to get down the road than if you're at 60% capacity on that highway and you can go the speed limit. A lot more cars will get down the road in any given amount of time in that scenario.
Throughput, 80 cars/segment/hour.
And by the way, it does feel a whole hell of a lot better to be in a car in that second scenario, right? Same way it feels better to be in a team that's limiting work in progress.
BTW, shouldn't we also worry about quality?
So those are a few metrics to think about velocity. But by the way, shouldn't we also worry about quality? Absolutely. And we thought a lot about how we don't want to go faster at the expense of quality, at the expense of releasing bugs that are going to negatively impact our users.
A cost arrow points up. Next to it, a graphic depicts increasingly larger bugs from left to right: regs, design, dev, test. Production. Text, major bug escapes, hash of major bugs impacting customers.
So we looked at major bug escapes. This is kind of thinking about how many bugs got out in any given period of time that impacted our customers in a significant way. And that's a good one to use.
Change fail percentage, what % of deploys result in failure?
In the book Accelerate by Forsgren, Humble, and Kim, they talk about a couple of other ones, which I think are worth mentioning. That's a great book, by the way, highly recommended. They talk about change fail percentage. So what percentage of your deployments result in failure? Because if a lot of them result in failure, that's going to draw down, that's going to be a bad experience for your users. It's also going to draw down the velocity of your team.
Mean time to restore MTTR, a building on fire.
And when there are failures in production, how long does it take you to actually restore service? So the mean time to restore, and that one correlates in really interesting ways with change fail percentage. You might have a really low change fail percentage, but when you do have a failure, it takes you a long time to remediate. That might impact your users more than if you have more failures, but you can fix them really quickly. So it's really interesting to look at those two in combination. So how did we in 2018, knowing that we wanted to improve our velocity, how did we choose and develop the metrics that we would use to do that? First of all, we explored our Jira data because everything we do at Indeed is in Jira. We track all of our work there. Every unit of work has a Jira issue.
github.com/indeedeng/emotep.
And so that's a good place to start. And luckily, several years before, we had built a data set using Emotep, which is our data analytics platform, that let us look at all the actions that occurred on Jira issues over time, including state transitions. So we could look at, in aggregate or at the individual issue level or at the project level, we could look at when, in a given point in time, an issue transferred from one state to another and how long it was in that previous state. This was great because this let us really start to measure things like delivery lead time. And we chose delivery lead time because as the metric that we would focus on for improving velocity, because it represents faster delivery of value. And it corresponds to higher throughput and encourages teams to reduce their, to eliminate their process bottlenecks. But it was really exciting, of course, that we could actually measure this and start to build up repeatable measurements.
Data on a dashboard for Indeed Global.
And here's the results of some of that work. This is a dashboard we built up very, very quick and dirty, but in early 2019, we took this screenshot. And I'll bring your attention to the number at the top. And this is across Indeed, across all software delivery teams, the average delivery lead time expressed in days for the preceding 12 weeks. And you can see that in early 2019, it was nearly 15 days on average. And the other numbers on here are how we tied this to more granular teams. So every row represents an organization. The first number in the row is the delivery lead time average for that organization, and then subgroups or teams within that organization are the rest of the numbers. And what's really interesting to point out here is that some groups or teams had fairly high delivery lead time, as high as 22 days on average, whereas some of the others had much lower delivery lead time, like 9 or 10 days on average. And this was really interesting for us to see early on, and a crucial observation, because then we could go and talk to teams at different points on this spectrum and see what was different about them, what constraints were they operating under, and was this metric, was this measurement going to work well for their team in improving velocity?
Indeed DLT in early 2019. A table classifies data as average, 14.9 days, 50th percentile, 8.2 days, 65th percentile, 14 days, 75th percentile, 21 days.
So again, early 2019, our average was 14.9 days. Our median delivery lead time was 8.2 days, and about 25% of issues took 21 days or longer to deliver.
2019 goal.
So we set a goal, actually before we even had all of that data I just showed you. We had taken an initial measurement and seen that at the end of 2018, the average delivery lead time was 14.1 days. Notice that going into 2019, it was going up. But we had that measurement and we wanted to set a goal for 2019. And we came up with this fairly audacious goal to double velocity or reduce the average delivery lead time by 50% and get it down to 7 days by the end of 2019. And this appealed to us sort of intuitively because we felt like most Jira issues should be deliverable in less than 7 days. But it was really important to me to answer this question. Is this even possible? Can we do this in less than a year? And so I took the 2018 data and I ran some scenarios on it. And I came up with one scenario that I'll share with you, which is that we could get our average under 7 days if none of those issues in 2018 had taken more than 14 days, and all the rest decreased by 30%. And if we did that, we would get under 7 days, and also we would decrease our median from 8.2 days to 5.8 days. So this sounded really difficult, but it also sounded not completely impossible. So what I said to our senior leadership in establishing this goal is, this is really ambitious. It's not going to be easy. And there's no one size fits all to get there. We can't deploy a single change across the organization that will get us to 7 days. It's going to require effort from every single product development team. And luckily, after I told them this, they still signed off on it, and we embarked on this process of trying to reduce delivery lead time. So what did we actually try to do to hit this goal? What did we actually do to implement this? So the first thing, of course, is defining the goal. I already talked about that. We're going to hit 7 days. Next thing is we communicated a lot. We had communication coming from senior leadership. We wrote newsletters. We made videos. We sent out emails. We held Q&As. And we did all this on a regular cadence. So in other words, we had a communication strategy and we executed on it.
Q1 versus Q2 bar chart.
And also, very, very important, we aligned goals across the organization. We wouldn't have gotten anywhere if we hadn't done this. So every group at Indeed set a delivery lead time goal for the year. And then we helped them track their progress towards that goal. And this is a picture we took mid-year to show to the senior leadership team to say, hey, all the teams Q2 over Q1 have decreased their delivery lead time already. We're making progress.
Delivery lead time bar chart.
Next, we delivered insights to teams because we didn't think that we would solve this unless teams had a good understanding of what they should do to get better. And we felt they were well positioned to figure out how to improve their process, but they needed to understand where their bottlenecks were. So this is a screenshot from a tool we built called Peregrine, which is an interactive velocity dashboard. And it lets you, at a team level, get down into it and say, okay, which parts of my process are taking the longest? What are my opportunities? Where are my big opportunities for improving delivery lead time? But we went a step further because once they actually identified what they needed to improve, they needed techniques to improve it. So we provided training and support. We had senior engineering leaders go around Indeed giving velocity improvement workshops where they shared techniques that would help teams improve their velocity. We also aligned individual incentives. So we encouraged leaders to value individual contributions to velocity improvement. And we also went as far as to modify our performance and career rubrics to clarify that this was something that we valued. And then finally, we measured, and we reported constantly on our measurements. We had dashboards everywhere. We had Slack notifications going to teams, content widgets that teams could use to report on their status towards delivery lead time. We did regular leadership reviews and regular company updates. And along the way, we definitely heard some concerns. And I want to share 3 concerns that I heard regularly from developers throughout 2019. First of all, the question of this, and especially at the outset, was, won't people just game the stats? And people had heard me talk about Goodhart's law, which says that if you take a measurement and turn it into a target, it ceases to be a good measurement. And so this was just something we had to be very upfront about that we wanted to avoid. We didn't want people obsessed about the number. We wanted people to focus on what matters, which is that we want to be able to explore more ideas, deliver more value, and maintain quality while we do it. And we want to be continuously improving. Now, that sounds great. And more cynically, I did point out to people individually that, hey, we're also watching correlated metrics. If you game the stats and you improve your delivery lead time, but your throughput doesn't go up, I may start to wonder what you're doing. And also, if you're cutting corners on quality to get your velocity up, we may notice that your production bugs go up. So we're going to watch these correlated metrics. Another concern I heard was, how will I be evaluated on this metric? And this one was easy to answer because we just said, you're not going to be. We're not going to evaluate individuals at performance time based on their individual delivery lead time. We're going to focus on the team, and we're going to focus on how teams are achieving real velocity improvements together, and we're going to celebrate when they do. The final concern I'll share, I heard a lot throughout the year, and it was always some flavor of, this metric is sometimes wrong. And let me tell you the case that it's wrong for. Whether it's this project or this particular issue, it's not giving an accurate readout of the delivery lead time. And my answer to this was always, it doesn't have to be right all the time as long as it's generally useful. And ways that it can be generally useful are, will it encourage, will thinking about it encourage people to take the right kinds of actions? Will it be meaningful in aggregate? And that means like across teams and over time. And again, like, it doesn't have to be perfect. We just have to be really clear on how we're using it and what value we think we're getting from it. And when people pointed out bugs with it, I committed to them in the future, we'll improve that. A lot of people were upset that we were using average instead of median, and there were reasons for that, but we committed to sort of evolving our tools to be able to focus more on the percentiles as we went into 2020.
You may be wondering if we hit the goal.
So I'm keeping you in suspense. It's mid-2020 now, and I haven't told you whether or not we hit the goal. So I'll finally unveil the bad news that we didn't hit 7 days on average. But we did reduce our average delivery lead time 40% to 8.5 days on average. And I think this is tremendous. I was super excited about this. And I was maybe even more excited to see what happened to the median delivery lead time, which went down from 8.2 days to 5.3 days. And remember earlier, I had a scenario cooked up that only got the median down to 5.8 and got us under 7 on average. And I think the median, the common case, is really, really meaningful. And I think we'll continue to drive down this median delivery lead time. I'm also excited to report on the correlated metrics front that throughput did increase. At the end of 2019, we had 24% more people contributing to our code base than at the end of 2018, but we increased the number of issues delivered by 35%, which is an 8.5% increase in per developer throughput, and shows that we reversed the trend that we were seeing, and that is really exciting for us. So what can you take away from Indeed's story of working on velocity improvement? I think, first of all, put velocity in context. What does it mean for your domain? What does it mean for your teams? How do your teams feel about it? How do they think about it? How could you measure it? Do you need to measure it to drive improvement? And if you do, like, how will you use those metrics to drive improvement? And I really encourage you to embrace this Kaizen philosophy of continuous improvement. Develop metrics, iterate on them, monitor for anything that might be undesirable from the process of using metrics. And maybe most importantly of all, celebrate all the wins. That's really important when you're metrics driven, to remember to step back and celebrate the qualitative stuff. It's really important.
Thanks. Indeed Engineering, Indeed Tech, blog, talks, open source, and great ideas.
That's all I have. Thanks for your attention. I want to thank my colleague Siva Dosapati, who helped me put together a longer version of this presentation previously. And I look forward to the panel discussion.